Hello and welcome everyone to another episode of Rustacean Station. This week we are covering This Week in Rust, issue 444. My name is Tim McNamara. You'll know me online as Tim Clicks, and I'm joined by co-hosts Alan Weimar and Sean Chen. How are you both?
Good.
Good. We got there's a positive and a negative. I'm going to throw in another negative. We've had food poisoning at home all week, so it's been rough. The agenda for today's episode is that we will go through the quote of the week, the crate of the week, the official updates, highlights, and then if we have time left, we will also just have a space for any worthy mentions that we didn't get to as through the course of the rest of the episode. Okay. Let's start with the quote of the week. This is the difference in approaches of the two languages. In C++, if the code is vulnerable, the blame is on the programmer. In Rust, if the code is vulnerable, Rust considers it a failure of the language and takes responsibility to stop even bad programmers, sort of quote-unquote bad programmers, from writing vulnerable code. I can't stress enough how awesome it is that I can be a careless fool and still write perfectly robust, highly multi-threaded code that never crashes. So this is a post or a comment in a Lobsters thread from a user called Cornell, and it actually relates to a discussion of one of the articles in This Week in Rust, which is kind of helpful, which is called Rust, a Critical Retrospective. And how does that quote land with you guys? Does it kind of enlighten you, or does it rub you the wrong way?
No, I think it's spot on. Well, of course, it's a little bit exaggerative, I think, in reality, but still, I think it's pretty spot on, right? That's kind of relates a little bit to one of the articles I'm going to cover today, actually.
We definitely need to get better at this. Rust community needs to definitely get a breadth of quotes, not just things that they love about Rust. Like in 3 weeks of platitudes, we need some decent criticism or something.
No, I think this is actually also good too, because another article I'm going to be, I don't know, actually the same article, they list this kind of like, so Rust is both good and bad at marketing, right? I think the good part is articles like this. I wish there was more of them, these kind of quotes. But the bad part is like, why should we write it in Rust? Well, why should we rewrite it in Rust? Because it's cool. That's what you always hear, right? That's the negative press, right, that we keep getting.
The crate of the week is rustdoc-types. It's a crate that provides types that deserialize rustdoc's JSON output. That is, in the -- output format JSON flag, all the types that are involved in the machinery are provided by this crate. And it's actually a re-export of a crate that sits internal to the Rust compiler or inside rustdoc and does very little by itself. It's just kind of a collection of types that are being exported. But it does actually provide another view of one of the things that I think Sean and I were talking about relating to parsing, and people that are into writing code just somehow love to write programming languages, and it provides an overview about how to represent Rust code as code. I would have really liked to have seen a full example in the documentation of actually how to point rustdoc at something and to kind of get the structured output out. But it's kind of definitely a crate for people that actually know what they're already talking about. On to the official notices. So we've had one official notice this week. The release announcement for Rust 1.1 1.6.1. Hooray, a new Rust release. Doo-doo-doo. Like sound the horns or something. I've got a button here for dramatic piano or drums. We'll try drums. No, stop. That was really bad. It was the wrong sound. Anyway, so Rust 1.61 has been released. The post outlines 4 main features that are provided by the release, and John and Ben are very likely to have an in-depth article covering all of this in depth. Have you guys been able to look at this post, or should I read out these 4 bullet points?
I'll admit I totally forgot to read it.
Yeah, I read it as soon as I saw it on Reddit. It's interesting. I don't think it's really huge for me, but it could be huge for other people.
So one of the things that you can do now is return a custom error code directly from main. So this involves implementing a termination crate, which is in the standard process module, and implementing a method that returns a U8 variable. The capabilities of constant functions or const fn have been expanded. There is quote-unquote basic handling of function pointers. The text reads, you can now create, pass, and cast function pointers to a const function. But it's actually, you're still not able to call function pointers yourself inside a constant function. Another thing that's kind of useful is that you can now provide trait bounds to generic parameters. For example, you can require that your type T is copy, whereas previously you were only allowed to require sized. There is also a note there about din trait and impl trait support, but that kind of went a little bit over my head because this isn't an area of Rust that I've explored in great depth. One of the things that I am really excited about, just from like a beginner point of view, is that the handles that are provided from the standard IO methods, that is like the standard in, standard out, can actually be locked directly. They don't need a sort of an intermediate variable anymore. The other thing is that several APIs have stabilized, which is always kind of useful if you're attempting to rely on Rust as a safe, stable target. The next section of the podcast is our highlights. And so each of us has picked 3 posts from the newsletter that we'd like to chat about. Sean, do you want to kick us off with your first pick?
Sure. I'll go ahead and start off with this developer survey that was highlighted, titled JavaScript and Python Reign, but Rust is Rising. It was just a fun little read, pretty short. And obviously what's most interesting is just the numbers they give. So again, I kind of find these fun to read. Starting off, this report mentions JavaScript has nearly 17.5 million developers. And Python is number 2 with 15.7. And they also add that in the past 6 months, Python added 3.3 million net new developers. As far as Rust is concerned, they say here that Rust adoption has nearly quadrupled over the past 2 years, going from 600,000 developers in Q1 2020 to 2.2 million in Q1 2022. I'm really curious how they got these numbers. They don't say anything about their methodology.
Right. Okay. So that was the immediate question, because I looked at this and saw that it was a survey of 22,000 developers, and somehow we're extrapolating to like dozens of millions of software developers. I didn't go. This is one of those free downloads where you're supposed to provide an email address and then you can kind of get the download. I didn't go and get the full report.
I mean, me neither, to be honest. And I'll just rattle off a few other interesting numbers as well. Java has nearly 5 million as of the beginning of 2021. PHP has grown the least in the past 6 months, an increase of 600,000 net new developers between Q3 2021 and Q1 2022, even though it is the second most commonly used language in web applications after JavaScript. And then, because we're talking to a Rust audience here, I got to mention that the Go community now numbers 3.3 million, according to this report. So about 1 million more Go developers than Rust developers. We can
But like, we're in the same kind of ballpark, right? Like, did it say that there were 2 million Rust developers?
2.2 million,
kind of crazy.
It's pretty crazy.
I mean, welcome to all these new Rust developers.
Yeah. Wonder what percentage of them listen to this podcast.
Clearly, everyone listens. I am very enthusiastic for Rust, although I'm very cautious because recently there have been quite a few things which are like, Rust is really difficult and Rust is hard to learn and it's really complex. And I feel maybe that's inherent, but I think that this is actually more imagined than real. I I'll keep my personal take and personal bias to the side for now. But it's really interesting that Rust is growing as fast as it is. It isn't a programming language that, like a domain. Systems programming is not something that is in some sense like a sexy area of program. Oh, maybe it is. But it's interesting that this language, which has kind of been incubated for building programming languages and compilers and file systems and other kind of big, heavy industrial software, is actually finding a much broader audience. And I'm really enthusiastic. I mean, the biggest thing about Rust that I really enjoy and appreciate is this focus on empowering people to get their own stuff done. Actually, from there, Alan, do you want to chat about your next pick? Because I think there's one or two posts that you've chosen that relate to this in kind of a slightly obscure way.
Well, I'm going to pick one that's different than what's related just to be a rebel. But I think this one's quite important too. There's a new Redis client called Redust, and I think it's quite interesting. So there's been quite a few people who feel that the current crates that they want to use are not quite up to what they're looking for, and they just go ahead and roll their own. And his big thing was that he really wanted first-class pub sub support. So that's what he favored, and he realized that basically, I think 3 out of the 4 that he surveyed didn't quite have what he was looking for, and so he also took it upon himself to write his own. I think the more interesting part is not really about the crate itself. Really, I think when I started looking at the comments, because this is actually on Reddit, I think the comments were actually more interesting, and I think they start to kind of point to something really. I don't know if it's good or bad for the community where. People are starting to roll their own crates instead of doing stuff upstream, right? And it kind of goes back to what Tim was complaining about before, or lightly pointing out to people out there that, okay, now which crate should I use? I want to connect to Redis, but which crate should I use? And so this could be both a good and bad, right? It's nice to have choices, but at the same time, if there's too many choices, you don't know what to eat. You don't know what to get. Because I'm thinking about eat because I'm thinking about when I go to a restaurant and you got 5 menus, I don't know what to eat. But if I have like 20 choices, it's much easier, right, to choose which one I want.
This is why it's a complete tangent, but hopefully we'll get some smiles out of it. This is why it's actually quite useful to be like a vegetarian or a vegan even, Because when you go to a restaurant, there's only like one or two things that you can eat, and it's very, very handy for avoiding that problem. But yeah, I read this too, so it was very interesting. The context of hi Reddit, why here are these Rust Crate clients for Redis. They all suck. Well, at least they all seem to suck in this one particular area. So I've done something myself. And then someone kind of pops up in the thing saying, oh, yeah, well, I've actually decided to become a maintainer for the Redis crate itself, and do you want to join me? And so these things kind of get resolved in the wash, or is that the right metaphor? I don't know. But I think you're definitely pulling out a very important problem. And I don't think that there is a direct answer for it. You can't just tell, let's say, 3 million people, presumably, that they all have to use the same Redis client. Or if they want to implement a new feature, they've got to port it upstream, because sometimes it is just easier to work off a fork, because open source is really complicated. You need to communicate with people. That's challenging. I mean, it's really hard to contribute to a repository that's managed by somebody else, because it's always nice to have this feeling of control.
It's interesting in this case. I don't know if anyone listened to my episode of Building with Rust with Josh Triplett, but we actually touched on this topic a little bit, where in the case of Rust, Rust is not really good at kind of sharing between crates. And what I mean by that is, if you have like some crate, and it gets a lot of usage, that builds up like an ecosystem around that particular crate. Right. And then those ecosystems are like kind of incompatible with one another. Right. If you look at like Tokyo and async stood and small and things like that, like those crates, Rust doesn't really have a lot of mechanisms for those crates to kind of interoperate in an ergonomic fashion. And so I think that's an interesting challenge as far as Rust is concerned, when you're talking about like, oh, these other crates suck, I'm just going to implement and roll my own. And in the case of Rust, that tends to kind of fragment the community a little bit, because again of this tendency for crates to just kind of form their own little niches and ecosystems that again can't really interoperate.
And I think that there's a good reason for this. Like there's a principled reason that you shouldn't be able to implement foreign traits for foreign types. Or is that kind of what you were referring to slightly?
That's correct, right? Like it has a lot to it all kind of stems from the orphan rule, the name of the rule you just mentioned. It was interesting though that I think Josh had the insight on that on our chat, that he was like, I think eventually down the line we probably need to loosen the orphan rule a little bit to allow some interoperability between crates in some kind of controlled fashion. We were just kind of, musing. So I'm not like saying this is going to happen or anything. We were just kind of brainstorming together. But that was an interesting piece of insight from him.
Well, I'll send the mob to you, Sean. They'll be outside your house, like breaking down the wall. I can't change the orphan rule. I thought you were going to change. Anyway, so I think it's my turn. The place where I would like to start is a long post called Rust, a Critical Retrospective. So this is actually the impetus between the quote of the week. It was a very well-read and very influential post, I think, when it was published, primarily because it was so good. Sadly, it's very dense in the sense that it is there's a lot kind of going on there. So allow me to flesh out some of the context I don't know all of it, but I know a little bit. So Bunny, the person who wrote this, is a very interesting and influential character in his own right. So he published a book in 2003 on hacking the Xbox, which was kind of cool. I first encountered Bunny in 2013 at a Linux conference. He was keynoting, and he was talking about building a hardware startup, this thing called Chumby, which was a sort of embedded firmware kind of stuff. What he's doing now, or at least I went to a similar conference in 2019 and chatted to him a little bit then. He is building a surveillance-resistant phone, like a security enclave that's much more secure than, say, Android or Mac OS, because it turns out that journalists and others are very vulnerable to state-based actors kind of snooping on their behavior. And he's trying to get this right. I probably have kind of details wrong there, so feel free to kind of investigate this yourself. But he does kind of mention in the post that security critical applications have issues when they talk when they rely on Rust. So there's one quote that I want to pull out from the post, which is, I'm not even sure if there's a good solution to this problem, but if you are super paranoid and your goal is to be able to build trustable firmware, be wary of Rust's expansive software supply chain attack surface. That is this notion that if you pull in one dependency, suddenly you kind of pull down like half of crates.io. And actually, any single crate can have its own build.rs file, which provides the ability to do whatever it wants. And this makes it very, very scary if you want to protect your users from malicious code being injected throughout the entire stack. So Bunny and colleague Zobs are creating a new operating system to work on their trusted firmware, which happens to be on this crazy CPU compile target, like inside a CPU that runs on an FPGA. So kind of nuts, but also amazing. The post has a lot of applicability outside of that, or a little bit wider. Just to say, we start off with there is kind of superficial, kind of a lot of kind of noisiness to it. We have lots of angle brackets. There are double colons. We've got ampersands throwing around question marks and lifetime annotations and this kind of thing. Just kind of all feels a little bit noisy, as well as function annotations and so forth can feel unergonomic, or at least kind of unfriendly to unfamiliar, or if you're learning. And then there was a comment that I found really good, which was that as time passed, I eventually got over the learning curve and became more comfortable with Rust, but it was a hard and steep curve to climb. This is in part because all of the Rust documentation is written in an explain like I'm 5 style, which is really difficult to generalize from. Or you're greeted with kind of a formal syntax definition, which means that technically everything you need to know to define a feature is in there, but it's never summarized in plain English. There's sort of nothing in between. And there is this complaint that there isn't enough in the middle. And many people would have experienced gaps. And that's partially because there are lots of people exploring Rust and applying. Lots of people are exploring Rust. Now, so those were the comments that I really wanted to pull out. The other one just. No, I'll just pause there and just allow you guys to wave at me and say there was some other stuff that I thought was really great.
Yeah, this was an interesting post. I had it picked at first, and then I was reading through it, and I was like, no, there's no way I can summarize all this. It's way too dense. So I changed my choice, and then Tim picked it up. But so I did read through it, and a couple of my favorite parts were you mentioned the code snippet that he was kind of like using as an example to highlight that Rust's syntax is very dense. But I love it because it's super clever and it reads trying to read a heavy syntax like this can be maddening. Map question mark. You won't really understand what I mean unless you go ahead and look at that code snippet in the post. But I found that delightful. I think the other thing I wanted to just mention at the very end, he's like, anyways, that's a lot of ranting about software for a hardware guy. He goes on to say, like, I'm a hardware guy. I'm not good at writing software. Don't ever ask me to write a linked list. You know, why would I ever want to do that? Don't I just pull a library down? And he basically is saying, like, you know, I'm not qualified to provide, you know, a critical perspective on software because I'm not a software person. But, you know, like, Bunny, I think you are absolutely totally qualified. I think you made that clear through your posts. I think you gave very very valid and very interesting criticisms. So I don't think you should, you know, sell yourself short as far as your qualifications of being able to talk about this stuff, because it was a very good post and I really enjoyed it.
Yeah, I thought it was a pretty decent post. I felt a little bit too complaining at sometimes. Maybe that's just my own thought process when I read it. So there's a lot of like, it's kind of weird. Like when I read it, like my feeling, again, this is just a feeling, right? Please don't be upset if the author's listening. But it was like, yeah, this is not good. This is, you know, this is why it's not good. But it's just a small thing. Like I was like, went a little bit in depth on something that was kind of like a small thing. But I appreciate he did go in depth, right?
Yeah, it's like those people that say, oh, I had, you know, like it doesn't really matter, but I'm still going to spend 10 minutes complaining to you about this thing that doesn't really matter. Like, oh, it doesn't bother me, but yet.
Yeah, that was what I felt too. And I'm glad it sounds like I'm not the only one who felt like that. But again, like I thought it was pretty interesting. It's always interesting to hear what people say about Rust because it brings stuff into a new perspective for you. Like the first part when he had that like very confusing syntax, I was like, okay, yeah, I don't even know what the hell that even means. Although he did make up the words, but I'm sure that the syntax style is similar at times. But then again, I think that kind of stuff is maybe, it depends on what you're doing, right? I think most of the time you won't really see that. I've never seen something so complex before. Maybe you guys can say if you've ever seen something so complex.
Yeah, I feel like that wouldn't pop up unless you're like trying to play code golf with Rust, which... you know, but like you can play code golf in any language and it'll look crazy.
I mean, you do crazy stuff when you write an OS, right? So I can imagine that you would see some crazy stuff. Sorry, go ahead.
Yeah, I was going to say, so if you haven't read this and you're kind of wondering what this kind of code snippet is, it is creating, I'm just kind of going back, kind of creating a struct or something or doing something with a struct and then kind of calling map on it. No. We're calling a static method with a lifetime, and then there's a closure in there, and we're kind of calling map on a closure, and we've got a question mark, which and so for me, I'm sort of immune to this as a problem now. So it reminds me of like Felina Hermann's book on. I think we've already talked about her before. What's her book called? It talks about memory and short-term memory. A programmer's brain, yeah. And people that are learning can't chunk up concepts in their brain. So they need to kind of learn, or when they're reading code, it's basically character by character. But seasoned programmers or people that understand the programming language can actually inherently chunk things together. So, for example, you might always see a variable as one entity, not out of multiple words, and therefore you've got more working memory. And so I'm kind of immune to this kind of syntactic noise problem, but it's definitely present. well, I say immune, but someone's going to send me through a obscure code snippet.
You
If
asked
you
for
do,
it.
yeah, that's right. So yeah, we should actually issue the challenge in the Discord server.
Only Tim is
which
issuing the challenge.
All right, I'm issuing the challenge, which is like, come into the Discord server. Let's throw our crazy syntax snippets and like kind of see like, is this really genuine Rust? Like, does this actually compile or something? Or I'll be interested to see what people come up with. We should get on with the rest of the podcast, though.
So I just have one last thing. Sorry. I did see a macro that he put in there. It was very interesting. It was like config all not if something. I forgot what exactly. It was very crazy. I was like, come on, nobody's ever going to write something like this. And then I took a look at the RFC that Sean's going to do. And in the comments, there was a crazy one like that. I was like, all right, this guy's point's valid. Sorry.
Yeah, look, the thing about having features is that eventually people use the features, right? There's like a famous Google, like the law of someone who the name sort of escapes me, that like given and it's kind of this informal definition that like there's no such thing as a non-breaking release, or that all of your behavior, whether or not you expose it as a public API or some kind of internal some sort of internal implementation tool, will become relied upon by someone downstream, especially once you get big. And Rust is big enough now that every single little thing is relied upon by someone. Okay, let's push on. Sean, do you want to give us your next highlight?
Yeah, so the next one I'd like to talk about is this post. I believe it's written by Lily Mara at One Signal called Fixing Memory Leaks in Rust. So this post details a memory leak issue that this team at One Signal encountered. And specifically, it had to do with an event system component, which was constantly being killed and restarted and killed again by the operating system's out-of-memory handler. If you were to imagine like a graph of it, it would look like a sawtooth kind of type graph. So there was like a steep, it exhibits like a steep climb because it's like accruing a bunch of memory, and then have a really steep drop because that's when the process was killed by the OS, and then it would restart and climb again and get killed and climb again. So it looks like a sawtooth kind of pattern as far as the memory usage is concerned. And yeah, we should caveat by saying, in case you're thinking like memory leaks, why is Rust getting memory leaks, right? I thought, the bar checker is supposed to protect against that kind of stuff. And generally, yes. I think the way I would put it is generally it's reasonable for safe Rust code to assume that destructor leaks do not occur. As in, objects in Rust all have a drop handler that runs when they go out of scope. That being said, it's entirely possible to purposely leak memory. There are functions in the standard library to do this, like stdmem forget or box leak. But it is kind of...
if I can kind of interject there, that's because actually a memory leak isn't considered a safety issue from the Rust sense of memory safety. Is that
right? It's only
understanding?
Right. The only thing unsafe about memory leaks is that they might eventually result in your program being killed by the OS, which is exactly the issue that this post is detailing. So the rest of the post goes on to detail, what was the issue here and how it was resolved. It turns out this component relied on, or the Rust code in this component relies on the tracing crate for distributed traces for debugging and diagnosing purposes. And when you are using the tracing crate to add that functionality to your code base, you basically manually specify in the code, like, here's a span and then here's a guard. Like, we're entering a span here, and then here's a guard for the entered span. And the idea is this is taking advantage of the drop trait to basically say, okay, we entered a span with this accompanying guard. Once that guard goes out of scope, then we exit the span. So that's kind of like an ergonomic way to basically make sure you don't forget to exit the span by, forgetting to call like a exit function or something like that. And this works really well in synchronous code. The problem was that this component uses a lot of async. And it turns out that this pattern of entering a span and using a guard does not work well with async code. And that has to do with the fact that because when you're in async code, there's a lot of threads running inside of a single OS process. And so when context switches between tasks occur, the tracing library is not equipped to handle that. So when a span or a span guard crosses a wait boundary, or another way to say that is like a context switch happens between tasks, then the span guard is not actually dropped. So it basically got allocated, and then a context switch happened and it didn't get dropped. So it just kind of stayed there and didn't get cleaned up. And so, all of these different task or context switches occurring means that you're basically just accruing a whole bunch of different span guards until basically, I think the post said it got to the point where the process had allocated like 17 gigabytes of memory, and then the out of memory handler would kill it. Was basically what was going on there, I believe, if I got that right.
You done a pretty good job there, Sean. Well done. You should have been contracted to write that article. The thing that got me.
I haven't said how they resolved it yet, but go ahead.
I was going to say, yeah. Did they resolve it? It's like,
no, they did.
The cliffhanger. No. As soon as I saw async and like the drop trait, I was like, this is going to be a bad day for somebody. So I just before we get to the resolution, I commend wholly the One Signal team for having the guts to basically put this out there that they had this horrible problem. It was really hard. Like, it was perfectly valid code. There was no kind of ability for them to know they were doing the right thing. We were just adding distributed tracing to our system. Like, this is supposed to make it much easier to diagnose problems. And they wrote a blog about it. So I think it takes a lot of courage and a lot of guts. And
I'm glad they did. This was not something I was aware of. So, I learned something from it. So, not everyone is aware of this issue, but I am now. But yeah, so there is a fix for this. There's this instrumentation or instrument trait, it was called. And that basically, once that was imported, it allows you to kind of configure the guard behavior. It basically allows you to extend the behavior of the poll of the future to basically say, because poll is where is basically where you cannot cross the await boundary. So when a future is being polled, that is not allowed to be preempted. So when a future is being polled, a context switch is not allowed to occur. So that's kind of like the functionality you want to hook into to basically say, okay, once we're done polling, drop the span, because that's like the time to do it. Because once you're done polling, then context switches could happen. So basically, this instrument trait, they hooked into it to basically say, okay, upon polling, once polling is complete, drop the span guard, and that cleaned up the issue, so that now every time a context switch occurred, then the span guard got dropped, and thus they basically resolved it to go back to normal expected memory usage. The last thing I want to highlight was kind of like the takeaways, which I thought were pretty interesting. So it turns out there's an RFC. That was an RFC that was proposed not by the One Signal team, so I think it sounded like this was already on the docket, but basically proposing, the ability to specify what types cannot be held across a waypoint, or to basically say, okay, I want to specify, or these certain types we're going to say are unsafe to be held across a waypoint. And so, the span guard types would be one such example. And so that would be adding that feature to the compiler. But that, it seems like it's a ways away. And so if you want something that's a little bit more timely, if you're, encountering this issue and want a more timely fix, the author did put in a PR to Clippy. So Clippy will be able to detect similar things as well, and basically give you a warning and say, hey, Clippy has detected that you have a type that is, you have a type that might be held across in a waypoint. The main trade-off there, so you get the timeliness because it's easier for the PR to land in Clippy, but the trade-off there is with Clippy, you basically kind of have to specify yourself in the clippy.toml file which types you want it to basically look at and check to see if they are being held across a waypoints and issue a warning. So that's kind of like the trade-off there. But I thought that was really interesting.
Cool. Okay. So it's interesting that we need to rely on, it's cool actually that we have two options, but it's interesting that for, in some sense, the more robust option, we actually need to get support from the language itself or from the compiler. Alan, hit us with your next pick.
Not with my best shot. But, okay, my next pick is, I'm glad only one person got that, I think. Anyways, so my next pick is building cloud database from scratch, right? I think this is definitely related to what we talked about earlier about, why use Rust. Very interesting. This team of self-proclaimed, now again, it's nothing negative, self-proclaimed 10 plus years C++ developers started about 7 months of code in C++ to write a database in the cloud. And they decided to change completely to Rust.
And they threw it out. They just one commit, boom. We're just going to take
one commit too. That was the best part, right?
Just hundreds of thousands of lines deleted.
Exactly. So, but the good part is that they did go in depth and they addressed what we talked about, at least what I said earlier, which is, why use Rust? Well, because it's cool, right? But no, what they found was that they were bringing on new developers, of course, as you do as a company, you start to scale, and they were hitting issues. And again, what Rust is really great at is finding these kind of issues they were hitting, which was just random bugs, concurrency issues, build system and tooling just not quite consistent, all these kind of issues that we always talk about in the community, they were hitting. And they said, you know what, let's seriously look at this and let's really be serious about this. They did it for about a month, okay? And then they said, all right, let's do it. And they rewrote it and they are not looking back. They're very happy with it. But they did have some complaints, right? That's great to have, right? It's good to have complaints. They're valid. The one was that they got into async, I think, a little bit too early without understanding that everybody uses Tokyo. So why even bother to choose something else for most projects, right? Not 100%. Another one is they talk about GAT. So I did see this talked about recently in the community. GAT, G-A-T, generic associated type. I have no idea what that even is. I tried to understand it. Maybe you guys can give some background about what that even is. That's a deep rabbit hole. Exactly. Yeah, that's what I feel like when I read it.
We're not going to get
trying to understand
today.
them for a while. I'm not there yet.
Even people that are in the Rust team, like the compilers, are like, I'm pretty certain that Nick Cameron had some statement like, I don't even know if this is required. This seems crazy, but I'm probably misattributing something. So hopefully I haven't defamed anyone.
In any case, this is the second time for sure that I've heard about this term, and they were not happy about that. But I don't know how not happy they were. There's one more other thing too, but I think in general, it's like apples to apple pie. It's like, this is just a much better experience, and we're happy with it, and we're sticking with it. Yes, not 100% everything there, no silver bullet as we know, but they're happy.
The Rust community is just so like lucky that Cargo was created. Like without it, we would have exactly the same problems of like which build system do we use? Are we going to integrating with Cargo or with like make files or like CMake or whatever else? Anyway, I will push us actually no, I'll allow Sean. Do you want to smile and nod?
Yes, I'm smiling and nodding.
Do you have any comments about this post?
Let's skip those. I think we are on a bit of a time crunch, so I think we should keep going.
Nice. Okay, so we are on a time crunch. Sean, do you want to tell us something?
Are we skipping you?
We are skipping me.
Okay.
Although I really don't want to, because I think I've got two that I can get through quite quickly.
I think you should just do it. It's okay. We have a little bit of more time on my side at least, so don't worry about that.
Okay, right. So I wanted to talk about deref and drop traits, a video that was published. Now, it is produced by a Microsoft software engineer, goes by the nickname Dan Logs or Dan Bugs. In this video, it's about 22 minutes long, and the author goes through the process of creating a smart pointer type and implementing both deref and the drop traits, and kind of does it in quite a lot of depth in a way that's really accessible. And so if you've been ever confused about what a smart pointer is or what is the deref trait and what is the drop trait, that's a useful video to check out. I think that actually kind of goes back to, we mentioned the drop trait in the One Signal post as well. The other one that I wanted to chat about was optimizing the size of your Rust binaries. The very short post on two useful flags you can add to your cargo.toml file to be able to shrink your binary sizes. I really would have liked to have seen a little bit more expansion on a cargo utility called cargo bloat and an associated one called Twiggy, which cargo bloat works outside of WASM and Twiggy works for WASM. Those two commands will actually help you to evaluate how much of an impact bringing on another dependency is going to have on the size of your project. And so I often see people say, this looks great, but I don't want to bring in another dependency into my project. The cargo bloat subcommand actually provides a way to discover empirically what the impact of bringing in another dependency has on the size of your crate. Wonderful.
That's interesting.
Okay. Yeah. Now, Sean, do you want to chat about RFCs?
Yeah. So for my last pick, I picked out an RFC. Specifically, this is a proposal that's open right now for adding more support for fallible allocations in the vec type. So I think this is also something we've talked a little bit about in previous episodes, specifically that Rust is getting introduced into the Linux kernel. But one of kind of the requirements for adding Rust to the Linux kernel is that more of the standard library methods need to be fallible. That's just a use case that is required by the Linux kernel. And so this is, I imagine, kind of tied to that. And this was an interesting one to read through. The gist of what's actually being proposed is, it's proposed that they're going to add a bunch of try prefixed methods. So like try append, try extend, try underscore, vec function, insert vec function here, to basically have them instead return results instead of just generally the infallible versions of what is usually returned by whatever vec method you are using. that wasn't really the interesting part to me. What was more interesting was kind of the motivation behind this particular RFC. They specifically stated that there are no plans to stabilize these fallible methods in the current proposed form. So really, this RFC is meant as a stopgap to basically unblock important ongoing work, like I imagine adding Rust to the Linux kernel, while better long-term solutions are explored. And so, because that was kind of the nature of this RFC, there was a long section detailing, the thought process that kind of went into why we picked this as a stopgap solution and what are some probably other longer term, or I should say, better long-term solutions that, could be considered in the future. Because the problem with this particular approach was basically just adding a whole bunch of new methods to vec and prefixing them with try and having them return results, is that it kind of bifurcates the vec API surface. So they say in the RFC, it adds another decision point for developers when using a fundamental type. And this bifurcation doesn't stop at just vec. What about other collection types? So this proliferation,
or whenever you might need to have collection type or something, whenever you want to allocate memory.
This will basically have like knock-on effects for the rest of the standard library and ecosystem crates. And so I want to take a little bit of time to mention some other interesting ideas that were thrown around as far as how this could be addressed. So one option that was deemed unnecessarily complicated was implementing both the fallible and infallible functionality as a single kind of generic method. But this really would complicate the internal implementation of vec, even though it would not actually expand the API surface. But keeping vec relatively easy to understand because it's in the standard library is a desirable trait. So that was thrown out. Another interesting proposal that I also found really interesting was this idea of we could actually under the hood kind of change vec's methods to be fallible and return a result on all of the vec methods internally. So basically all of the vec methods would return a result with the types of the variants inside the result actually would be based on what allocator was being used when that code was built. So basically you could have like a fallible allocator, and in that case, it would return a result, and inside the result would be the type and some kind of allocation error, presumably. And then because you use the fallible allocator, you would, if you got an error, you would handle that in whatever way was appropriate for your application. The interesting thing was, okay, what if you use an infallible allocator? And then in that case, the vec methods would instead return a result with the type, and then the error would be the exclamation point, which is the never type, indicating we're never going to get an error in this case. And you could then add some compiler magic that would coerce that. It's basically special case that result to just take the T out and not handle that result. And that would kind of be like under the hood magic that whoever was for the average user who didn't need vec to be fallible, they would just presumably the infallible allocator would be the default one, and that would just the API would act exactly the same, presumably, right? And I thought this idea was really clever on the surface, but and presumably it would not cause any breaking changes, right? That kind of seems to be the idea, but it turns out that that's not actually the case. It would still actually be a breaking change since the current fallible behavior. It would still be a breaking change. And then, sadly,
compiler hackers are not wizards, right? So they can't make everything like just the compiler just be perfect all the time or something.
Yeah, and then the last one I wanted to add was also just kind of like the implicit nature of this proposal and how we're basically hiding a lot of details under the hood. Kind of goes against the explicit philosophy of Rust. So those are kind of like the downsides of this particular very clever idea.
Well, thanks very much for bringing this to everyone's attention, Sean. I think it's quite intimidating if you are not exposed to developing a programming language this idea that actually you can participate. I want to bring up a comment that was made to me in private because I've been toying with the idea of becoming a Rust C contributor, particularly on the standard library side. And Ashley Mannix has sent me a really lovely note, which was, Rust is also chronically friendly. So nobody gets chewed out for making mistakes. They happen, they get caught, they get patched. You learn something new, it's okay. And so this was in a private message, so it's not public anywhere, but I just thought that that comment may resonate with other people. And if you feel like engaging in these discussions, I guarantee that you will encounter a warm and welcoming community, and you should absolutely do so. Find a way to engage. Now, we are fighting the clock. I don't know if you want to give us 30 seconds on your last post, Alan.
Yeah, I can be quick for this one. Last post is how to use Rust, SQLX, and Rocket for Also Cloud. So Also Cloud is an authorization service, if I understand correctly. And they chose Rust, and that makes it easy for them to, if I understand also again correctly, they export different libraries. So they make a dynamic library using Rust, link it into the programming language, and then deliver that. So basically, kind of easy portability of their logic. And then they use that same code to also deliver a cloud-based solution. And they use Rocket and SQLX to actually do this. It's pretty cool. So they built up a bunch of APIs. And the interesting part is they're actually using SQLite with Lightstream to make it because one of the things is you have to be very fast, right? And so obviously having a file system, it's probably much faster than going over the network. And then also that they need to distribute this around the world because you have to have it service very close to your application in order to be quick. And this seems to work with them. And one of their pain points is that even though Rocket is really, really friendly, the macros are great, but still the community is not as far along as you are with, say, Ruby or Python. So they still have to roll their own things, such as using GitHub Auth and custom integrations such as Honeycomb.
Okay, wonderful. Thanks both for spending an hour or so with me today and for all of our listeners on today's episode. A couple of comments from the rest of the newsletter. There are dozens of meetups to participate on. There are actually lots of important release notes. Two that I want to pull out are Data Fusion 8.0 and the IntelliJ Rust 2022.1 update. Please join us in the Discord service and say hi in the This Week in Rust channel. We'd love to hear your feedback. And other than that, have a great week. And I'm looking forward to Alan's interviewing dropping on Friday. Presumably you've got an interview dropping on Friday, Alan?
Nearly every Friday. I didn't know I should answer this kind of question. It's understood.
Alan is nothing if not consistent.
That's right.
I try to be consistent, yeah.
You're doing a very, very good job. Thank you very much for keeping the standard up. And with that, I'll say goodbye. Take care all.